Hello, in this discussion we're going to be talking about applications involving right triangles. So let's begin. So whenever time you deal with a right triangle, you always deal with the Pythagorean theorem, c squared equals a squared plus b squared. And as we've demonstrated before, there are many proofs to this. But one thing we don't discuss very often, which is true though, is the two angles that are not the right angle are complementary. So angle A and angle B adds up to 9 degrees. Now we're going to solve this right triangle. So this time we're given the B, which is 2. We don't know angle B. We're given angle A, but we don't know little a side, and we don't know the hypotenuse C. So they begin with finding the angle B first, and that's 50 degrees. So we place that in there. Then tangent of angle 40 degrees is A over 2, and the cosine of angle 40 degrees is 2 over C. Remember, the tangent is opposite over adjacent, and that makes it A over 2. And the cosine is adjacent over hypotenuse, which makes it 2 over C in regard to the 40 degree angle. And then you use algebra and your calculator. So little a is 2 times the tangent of 40 degrees. That's by multiplying 2 to the other side. And then using your calculator, that's 1.68. Alrighty? So 1.68 is the little a. And then little c is 2 divided by the cosine of 40 degrees. And you approximate that to be 2.61. Now remember, when you're calculating these two trig ratios that here we have here, make sure your calculator is in degree mode. A lot of times on a previous problem, you might have been in radian mode and you forgot. And that's the first thing you do whenever you start fresh on another problem, when you're trying to evaluate a trig ratio, is to make sure that they are in the correct mode. Something else you need to pay attention to here is how the sides are equal. Notice the hypotenuse is 2.61, and that's the longest side that I have. The other ones are 2 and 1.68, and that should be the case. But not only that, the side opposite of the smallest angle, they're also the same. So 1.68 is the smallest side, and the angle A, the angle that's 40 degrees, is the smallest angle. So the sides and the angles are unequal in the same order that are opposite of them. All right, let's look at another one. Here A is 3 and B is 2, and we're going to find the little c, angle A and angle B. Really, there's not any order that you really need to go through here. You can find angle A first by taking the tangent of angle A equals 3 over 2. You could find angle B first, and that'd be tangent of angle B is 2 over 3, and solve for angle B that way. But they chose to use the Pythagorean theorem to figure out what little c is. So 2 squared plus 3 squared, square root of 13, which is approximately 3.61. And notice 3.61 is longer than either of the two sides. Now, can you tell me which angle is going to be the smallest? Is it angle B or is it angle A? Angle B is the angle opposite of side 2, which is the smallest side, so therefore it's the smallest angle. And angle A is the middle angle. So what we do is tangent of angle A is 3 halves, and that'll give me angle A, which is the tangent inverse of 1.5 if you wish, which is 56.3 degrees. And so we place that in there. Now you can do the tangent of angle B, which is 2/3, and follow the same procedure we just did, or we can use the idea that these angles are complements to each other. So if the one angle is 56.3 degrees, then its complement is 33.7 degrees, which that would be what angle B would be. And so that's how you solve a right triangle. They give you 3 of the unknowns, and then you either use the Pythagorean theorem or some of your tangent ratios or your sine ratio or your cosine ratio, one of your trig ratios, to figure out the missing angles. That's the procedure. Okay, so if you have any questions regarding this discussion, you let me know, and you have a good day.